All right, so welcome to your Thursday evening dose of astronomy. I'm Irene Pease with the Amateur Astronomers Association of New York, and I'm learning a little bit more of OBS and streaming this week, so having fun with that. Um, you can find more AAA events at AAA.org. You can follow us on all the social media channels at AAADOTORG. That's our handle for everything. And also, here we have the different programs that I'm going to be using tonight. OpenSpace, which you can find and download for free at openspaceproject.com. It's freeware. It lets you kind of fly around the universe in 3D. So that's what you're seeing now. And we'll use that to explore more of Mars. And then also I'm going to be using some Stellarium, which you can also download at stellarium.org. So I use that for a lot of kind of my planning for observing, finding comets. If you haven't found the comet yet, you can use it to help you find the comet, that and other apps and articles online. So I'm not going to be talking too much about the comet tonight. Tonight is Mars or bust. So I'm getting really excited about Mars because there's a launch coming up in 2 weeks from, today. So I'm mostly going to be talking about that. But let's go ahead and jump over and see where we can see that in our night sky. So with Stellarium, we always like to start off kind of around sunset, which is soon. And so I'll go ahead and click this forward to about 10 o'clock tonight. We have some other planets that are going to be up. You can see Jupiter and Saturn labeled there. So they're going to be with us through the rest of the summer into the fall. They're going to be doing a really cool thing in December, so more on that closer to date. Mars isn't up yet. Mars is, not really up in our sky. So why am I talking about Mars? Well, let's see, if you get up at midnight, or if you're still up at midnight a little bit later, Mars will be rising over there in the east. And so it'll be out in the sky earlier in the evening as we get later and later into the fall, late summer and early fall. In fact, it'll be getting brighter. So that's kind of an exciting thing that Mars does every 2 years or so. It's just shy of 2 years. We pass Mars in our orbit. And if we look at this, so the class I was teaching this week, we talked about magnitude, like how bright things are in the sky. So the magnitude of Mars is going to get brighter and brighter. So higher numbers are dimmer, lower numbers are brighter. So this negative number, that's pretty bright. So tonight, tomorrow, it's going to be negative 0.79. If we kind of move through time, it's going to get brighter and brighter. -1. August and September, it should be even brighter, higher in the sky, so better view, -1.6. So it's going to keep doing that until it gets to some maximum point. So Mars is going to be kind of a star, well, not a star, but the metaphorical star of the sky later this fall. So late summer, early fall, everyone's gonna be talking about Mars. So I'm just trying to get a jump start. So starting early, can't start too early. So but that's Mars in our sky. It's kind of orangish, a little bit of color to it, not super red, but it's relatively bright and not always. I'm going to talk more about that in a minute, but as of now and then through the next several months, it'll be getting brighter, and then it'll start fading again after October, after early October or so. So to figure out like what Mars is actually doing in the sky, I wanted to show an image. It's kind of a little bit of a shout out to some of the other work that I do in all my spare time. So this is just a screenshot from the Hayden Planetarium video blog Skylight. So I can maybe put the link in the comments if I'm clever enough. So what you're seeing here is Mars at multiple close approaches. So like I said, about every 2 years, it gets it gets relatively close to Earth, but not all close approaches are created equal. So yeah, that link isn't working. Just kidding. So not all close approaches are created equal, but here we can see that the last close approach, which was in 2018, Mars was like one of the closest points that it gets to us. Not quite the closest, but very, very close. So it looked really big in our sky. For this year's close approach, that's going to be, again, on October 6th. That's going to be a little bit further away, so not as big as it was in our sky in 2018, but still pretty impressive, like way better than it was back in 2010. Like, oh, look at that, wah, wah. Not very exciting. So, so this close approach that we had in 2018, that was the closest one for the next, well, then it was 17 years, so another 15 years before it's that close again. So you can watch this whole video on the Hayden Planetarium blog site. If you just look up Hayden Planetarium blog, Skylight, Mars, you'll find it. So, so that's that. So, so popping over to OpenSpace, then we can go ahead and take a look. Oh, and actually, yeah, just real quick, this is Mars, or sorry, this is Earth's orbit going around here. So again, this is where we would be. So I actually want to kind of play through this piece of time kind of between now, like where Earth is now in its orbit, and we'll see why we're launching when we are. So I'll go ahead and it's a little peek at the GUI. And actually, I'm going to try just one thing. Bear with me. This was me trying to stream things. Okay. That didn't work. All right. So so here we are at Earth. All right. So there's most of our globe. And so I actually have time set for 2 weeks from now when we're going to be launching this. And so we can go ahead and kind of see what that launch is going to look like. Actually, what I wanted to kind of check out, because we have it in here, is the little bugger itself. So I believe we can zoom in to Perseverance. So if you're familiar with the Curiosity rover, then Perseverance should look very familiar. We move in here. It's another kind of little tank. Yep, here we go. So if you want to learn more about all the instrumentation, go check out NASA's websites. They have all kinds of information about the science and all the specs. So I just wanted to, quick visuals, also what we used for the thumbnail for this. So, but it has some cameras, it has all the science lab stuff, and it has a helicopter. So that's a really exciting thing to be doing, just to be able to fly around on Mars. So we're sending the first helicopter to another planet. We sent cars to the moon, which was pretty amazing. So people went driving around on the moon, like you do. But now we're going to send a helicopter to Mars. So so the package includes not just this really cool mobile science lab, but a helicopter as well. So the helicopter is going to be called Ingenuity. That was named by a high school student, I believe. And again, the rover part, that's Perseverance. So the Mars 2020 mission. So let's go ahead and just see what that looks like. So we'll head back, see if I can find the Earth. Not super gracefully, but there's our Earth. Yeah, and basically kind of follow the flight path of this thing. So why are we launching now? So I want to go ahead and turn on the orbits for the planet. So you can see where the Earth has been coming from and what direction it's headed. And move out a little bit so we can see that. And we can see Mars's orbit. So there's our moon. So where are we relative to Mars right now? So that green line, that's the flight path for Mars 2020 for Perseverance. So there's that inner line, that's Venus, and then out here we have Mars. So this is just kind of like a little piece of what you can see more in that other video from Skylight. If we run through time, so I'm going to set time to going just a few days per second here, and we can watch and see them taking off. So the inner planets move faster than the outer planets do. That's some of the Kepler's laws of planetary motion. And so the Mars 2020 has to launch away from the Earth. It has to kind of escape our gravitational pull. But then once it's kind of out in the solar system, it's going to have to slow down relative to Earth. If it goes too fast, then it'll go right past Mars. So Mars is traveling slower than the Earth, so it's going to slingshot and it's going to pass out beyond Earth's orbit and then get further closer to the orbit of Mars. And if it doesn't go too fast, then it won't go past it, it'll actually meet it. So we have this relatively narrow launch window. The launch window is between July 30th and August 15th. So it's just a 2-week launch window. And then I'm just going to pause it and kind of recenter here. So then the probe should be getting there, or the package should be getting there in mid-February, mid to late February. So I think the splashdown date is scheduled for February 18. And of course that could change based on the actual launch date. So if you watched one of the more recent launches with the SpaceX launch, you know that, sometimes things get delayed because of weather. We have this whole atmosphere thing on Earth. So here we are. This is early, like late January now, getting into early February. You can see them getting closer and closer. Is it going to miss it? It looks like it's going to go past it. I don't know. I hope not. And there we are at the 18th, and they should, basically intersect. So, so that's the plan. So NASA's pretty good at sending things out into the solar system and landing little robots on planets that are far, far away, safely, safe landings. It's, all this delicate stuff. We don't want it to literally splash down. We want it to like softly hover downward, very gentle, very gradual. And then it's kind of showing, I don't think it shows exactly where this is going to end up, but it shows some other stuff here. So yeah, so I think that's date sensitive too. So this is not the landing site, but today really I just wanted to spend a bunch of time looking at more of Mars terrain. So I know we've explored a little bit of Valles Marineris in the past. So this huge chasm that cuts across a big chunk of the planet that's the size of the United States, going across Mars. And then there's this Tharsis region, this very volcanic region. So I wanted to look at a couple features, two in particular. We'll see what we have time for, but some slightly similar features, and then we'll see if we have time for other things. So coming in on kind of this volcanic region, Olympus Mons, some of you might recognize. So that, again, is the largest volcano in the solar system. And I'm just going to try one more time to fix my window. See if I can't. Nope, that's not it. See if I can't. Sorry. Make it smaller. Wow. There we go. Sorry about all that. So yeah, so that's Olympus Mons there, largest volcano in the solar system, and it's much higher than Mount Everest. It's it actually like sticks up kind of out into the out of the lower part of the atmosphere. So that's kind of a destination. I do want to get there one of these days. Um, so if not today, we'll be talking a lot more about Mars later when Perseverance is more on its way. So first we have to get it launched. But I want to go ahead and turn on some of these higher resolution maps here that we have. So just taking a look at our Mars. So this map is really great. It's not super high resolution. We have much higher resolution layers that I think we've looked at before. And the one that I want to use is the HiRISE data. HiRISE has been imaging all over Mars, but it's a lot of data. So getting these data sets loaded in and set up and patched where they belong is just a tremendous amount of work. So there's a whole bunch of people working on these, a lot of interns and other folks who know more programming than I do to get all these data sets, and then you're able to access them with OpenSpace. So again, OpenSpace, that's basically the platform that I'm using, and then we're loading like all this data in. So it's a lot of data. And you can see like just these little patches that are super high resolution. And when I say super high resolution, I mean like it could see my iMac. Like if my iMac were on Mars, we'd be able to make it out. So it's about a 30 centimeter resolution. So yeah, anything that's, 30 centimeters or more, it could actually pick out. So kind of coming down into these two patches that are a little bit east of Olympus Mons, where all this volcanic activity happened long, long ago. It's no longer active. But back in the day, we have these kind of scratch marks. So you're saying to yourself, self, what's all this? And they almost look like, like a flow of, water. Like it could be, water flowing, like part of a river. And that's what we're going to see in another part of Mars. But this is a flow, but it's from lava flowing. So if you've ever been to Hawaii, there's these like lava tubes you can go crawling around in, or actually walking. They're pretty big. We have lava tubes on Mars. So if you like lava tubes on Earth and you want to go to Mars someday, you can, go compare the tubes. So these have already they're basically exposed, but these were basically carved out by lava long, long ago, and we're still loading in some of the resolution here as we go. But they're big. Right? I mean, so like you could definitely fit a person, you could definitely fit a car or 2 or 10 in there. I'm not sure how big this one is. They do get up to 250 meters wide. So I believe we could fit several buildings in here at the depth that we're getting down to. But let's go ahead and just kind of let this load in. And just one of my favorite things to do with OpenSpace is just literally fly around and be like, I'm just going to go for a little drive on Mars because I can. And tonight I just wanted to take you with me. So here we go down into a lava tube because we can. So you can see these probably had much steeper, well, they're still pretty steep, but more extreme cliffs back in the day when these were first forming. But we can see some of the erosion. Some of the kind of landslides have made way so that they're a little bit more sloped now. We have a bit of a shadow there on the left wall of our little canyon that the tube is kind of carved out. But and I'm just seeing some of the comments that from Mars, does the Earth ever transit the sun? Yes! And I think I actually showed that in the last Mars video. So if you go back and look at the, oops, I know what I forgot. If you go back and look at the other Mars video that I did, it's in the YouTube channel for AAA, we actually pointed out that there's this transit happening. So I think I even gave you the date for that. Pretty sure that's on there. So check it out. So they just turned on the height layer that goes along with this super high resolution color layer, and we can just squeeze right down in here. Whee! How big is this? I don't know. Up to 250 meters. Again, that's all I got. But you could just kind of like, go for a walk through here. So again, you can kind of see like the more like landslides have kind of eroded this away. Not some weathering in the past, and then so just some instabilities is still loading it a little bit. Yeah, this is just like really massive, massive data. So I might have to get a better connection to stream some of this better, but you kind of get the idea. Just these really beautiful canyons. So if you load OpenSpace, I'm just going to pitch OpenSpace like I always try to. It's really fun to just kind of fly around and see this. So even like up on the surface where you don't have those canyons per se, you can see kind of these features that look like flow features. But again, on this part of Mars, it all would have been from lava flows. So not water flowing, but lava flows. And then over towards the west, we see rising up towards the stars. We wouldn't really see the stars during the day, but that's Olympus Mons up ahead. So that would be a kind of a fun place to go hiking in Mars. Just hike down into a lava tube and then just sit and watch the sunset over Olympus Mons. Kind of neat. So so let's go ahead and take a look then at where this next mission is going to be landing. So it's not near the volcanoes. Let me pull out and away so you can get more of a bird's eye view of more of Mars. So it's going to be landing more in the region where there would be flows from water, so ancient flows from water. So we saw some ancient lava flows. Now we're going to look for these ancient water flows. And I'm going to switch out these maps a little bit, turn off those, and I want to turn on this other kind of color layer that actually shows elevation. So I think I may have shown this previously also. So we have elevation maps of Mars. So false color that's slowly loading in there. We have gives us kind of an idea of what Mars was like a long, long time ago. I go ahead and play through a little bit of time. I need the sun up over here. So there was probably a huge northern ocean way back in the day. So the blue, that's lower elevation, and then the reds and oranges, those are higher elevation. So we'll see that overall the southern hemisphere of Mars is higher elevation than the northern hemisphere, with this one kind of huge exception, Hellas Basin, this big chunk. So this is Hellas, and so that's kind of like one of the easier spots to pick out on Mars, is like this big light feature. And then we're kind of be looking up. We're going to be looking up by this northern ocean. So the ocean that would have been here long, long ago would have like rivers and things flowing out into it. So the other thing I'll mention, if you watch that other video, like you can see some of the light and dark features on Mars that could be visible through a good telescope on Earth. So if I turn off our false color, you'll notice that the basin is very light in color, and then that helps also with this area, helps contrast this darker area. So this is Syrtis Major. So that's one of the features that kind of stands out on Mars. In a telescope from Earth, you can kind of see like these dark markings if that part of Mars is turned towards us. So that's really nice. So we're going to come in here and the lander, we're basically looking for indications of ancient life, right? Everyone wants to know, like, life elsewhere? Oh, well, we're working on it. By we, I mean, science and NASA and people in general, not me in particular. I'm just your tour guide. But we can see we already have these high resolution images of the landing site. So we're coming in, this is Jezero crater in here. And that was possibly an ancient impact, but we're going to see there's basically this big basin where a bunch of water emptied out from a river. So you can still kind of make out the ancient riverbed if we come in here, and we'll be able to see like huge riverbed. Think huge riverbed. So when you think of a huge riverbed, or huge river on Earth, you think of like, you know, the Mississippi, the Nile, Yangtze, right? So huge rivers, things that like all the Star Trek shuttles are named after. So you get these huge alluvial fans where they empty into a larger body of water. So as the river's, you know, chugging along, it's carrying all these sediment because you have all this moving water. But then when it slows down, when it hits this larger body, it drops that sediment. So you get these alluvial fans. So this is an alluvial fan on Mars. It's like this big old like ancient river delta where the river came in, and you can even see like some of the parts where it would have carved out. And this fan here, like this is where there would be, if there's going to be stuff, this is a really great candidate for where there could be signs of ancient life. So if you think about, you know, all the stuff that's deposited Mississippi River Delta, like it's the super fertile soil because there's all this like organic gunk, for lack of a more scientific term, that's being deposited there. So really good place to look on Mars, see if we can find ancient microbial life. So this is the landing, proposed landing site right in here between these dark spots. So we'll be coming in. We, as in, you know, everyone watching the thing coming in and landing with the rover, and then it'll have that the helicopter as well. So the helicopter, I'm not sure exactly what range it's supposed to be. It's a really small helicopter. It's like a meter, just over a meter in diameter for the blades, but it'll be able to kind of pop around Mars. It's and like make little samples, and it won't actually bring anything back, but it'll do some sample preparation for, you know, possible future missions. So when Perseverance lands, this will be kind of the view. All these dunes, so just kind of covered in dunes. So it's going to have to make its way through all these dunes, and it's going to kind of make its way up towards that fan that we just saw, and then kind of up along the ridge of the crater. So kind of sampling as we go. So like way out in like what would have been this ancient lake bed. So really interesting rocks there. Like on Earth, we'd find all kinds of evaporites. So you have, think like, you know, salt flats. If you have some big body of water and then it dries up, it leaves behind all these minerals that like evaporate out of the water. So evaporates. So there should be some really interesting minerals in all these dunes. And then as you make your way over to the fan, like that's where, again, we're going to look for, you know, more organic materials, maybe ancient little microbes. So we'll see what we can see. I did actually look up to see how fast those propellers are supposed to be going. Because I was curious. I'm like, it's a much thinner atmosphere. It's a small percentage of the density of Earth's atmosphere. And I got that there were 2,400 rotations per minute for those. And the thing is about like 4 kilograms, so it's a lot smaller in mass. So there's less to lift up. So that's actually a lot faster than, you know, regular helicopters, you know, that go flying around New York City or whatever, but they're also more massive. So the thing is smaller, so lighter, which is great, but then also very thin atmosphere. So yeah, so they're really cranking it out. But it has solar panels, so it's like self-powered, self-contained there. As is the rover. They have bring their power with them. The sun is already there, so, well, the sunlight, not as much sunlight as there is here on Earth, but still sunlight. So hopefully in another year or even less, we'll have a lot of really cool images from this part of Mars and be starting to learn more about what it was like there billions of years ago. And I'll tell you all about it, or you can probably read all about it elsewhere. So we're just gonna kind of move up, I guess, a little bit out of the atmosphere, kind of zoom away out to the beautiful sky. And we'll just say thank you so much for joining us, as always. Again, I'm Irene Pease with the Amateur Astronomers Association in New York. Check us out. We have classes for members, we have meetups, and in normal days we would have observing, so stay tuned to see, if and when we can do some of that with the public. Should be a lot of fun. And again, just thanks to our OpenSpace and Stellarium that we've been using to visualize all of this. So again, thank you, and be safe out there. Have a good night.